Yes, good morning students. In the last videos we discussed about various concepts related to illumination engineering, and we solved some of the problems on also in illumination engineering, and we discussed the different concepts, different types of lamps used in the illumination engineering, right? In this session we'll discuss another very important concepts related to this illumination, that is a polar curves. Polar curves are nothing but they are curves which are drawn to find out the luminous intensity of a particular lamps. So polar curves are nothing but they are the lamps, they are drawn to drawn to find out the luminous intensity of a lamps. Okay, so in most of the lamps or in the light sources, the luminous intensity is not same in all the directions. Okay, so it is not same in all the directions. So if the luminous intensity, that means the candle power is measured in the horizontal plane about the vertical axis, right? Are you getting? The candle power is measured in a horizontal plane about the vertical axis. Okay, and the curve is plotted between the candle power and the angular position. So that is called as a horizontal polar curve. Polar curves are nothing but they are used to measure the candle powers or a luminous intensity of a line. So here what happens? So the candle powers is measured in a horizontal plane about the vertical axis. So the candle power is measured along the horizontal plane about the vertical axis. So that is called as a horizontal polar curve. Okay, so in the candle power measurement, what happens? If the candle power is measured in the angular positions, that means in a angular positions in a vertical plane, different angular positions in a vertical plane, so that is called as a vertical polar curves. So if I will repeat once again. So the candle power is measured in the horizontal plane about the vertical axis, and the curve is plotted between the candle powers and the angular positions. So that is called as a horizontal polar curve, or your horizontal polar diagram you have obtained. So if the candle power is measured at an angular positions in a vertical plane, so candle power in a measured in a angular positions, so different angular positions in a vertical plane, so you are getting the vertical polar curve. Okay, so here this will be your horizontal polar curve. This is the representation of an horizontal polar curve, and this is a representation of an vertical polar curve. Okay, the mean horizontal candle powers of a lamp can be founded from your horizontal polar curve by determining the mean values of candle powers in horizontal directions, right? The mean spherical candle power, okay, the mean spherical candle power and the mean hemispherical candle power can be found from the vertical polar curve. So here what happens? The mean horizontal candle power of a lamp can be found by horizontal polar curves, whereas the mean spherical candle power and mean hemispherical candle power can be found by using the vertical polar curves. Okay, these are the difference between the polar curves. So how to find out the how to find out the MSCP and MHCP using a vertical polar curve? So can be drawn using the Russian's criteria. So what it is? So it is a graphical representation, or a, it's once again that the Russian's construction is nothing but here they are constructing the polar curves for the light intensities of a lamp here. Okay, suppose you can just assume a vertical polar curve is in the form of a two lobes of symmetry axis y o y dash. You can see here you have a two lobes of symmetry, it's a y o y dash. Okay, so draw the circle with the convenient radius. So draw the circle from this point with a convenient radius. Okay, convenient radius with the center O. This is a center O. By taking a center as O, draw the circle with a convenient radius. Okay, then you draw one parallel line C to D here. So parallel line CD. Yes, just a minute. So you just draw the parallel line CD. Okay, which is parallel to Y O Y dash. So the line is parallel to Y O Y dash. Right now, draw the line inclined at an angle theta. So this you would just draw the line which is an inclined, draw the line which is inclined at an angle theta from the point O. Okay, and then draw an angle theta and draw OFA. That means you just draw that line OF, that is Russian criterion. So to it will touch to OFO, and it is extend the line towards the CD. Extend the line towards CD. Okay, so CD line, you just extend this line towards the CD. Project that A on CD. That means here you draw one line and then project line on CD plane here. Let the projection be G. So let the call it, this projection will be as a G. So at this G, erect an ordinate, okay, GH. So at this particular G, you just erect an ordinate. So just this means extend it, that is called as a GH. Okay, that is equal to OF. So GH, you just erect it, erect it to some value. So how much you should erect? So the radius should be O and F. Okay, so by similar construction, complete the complete figure. That means this is I have shown for one construction, that is O to A, then to G, erect it. The erection line should be OF. Okay, similarly for all the radiations, you draw that Russian's criteria. So this erected line should be based on the same funda which we are used to draw this AG. So for all the radiations, you draw this one, then you just close it. Then you just join all the points. Okay, let the intensity of illumination I at any angular position in theta, that means any angular position, any angle, this angle, this angle, this angle, whatever the angle theta, is considered a differential angle d theta and rotated above the axis. So it is considered at, so the intensity along all the planes will be considered as theta. Okay, this is how you are projecting your light intensity, lights from your curve. You are plotting the polar curves for different angular radiations, and then you are passing them on a parallel plane. So by measuring the intensity on that particular parallel plane, you can find out the you can find out the mean. So by taking the mean of the candle powers of all the intensities, by taking the mean of candle powers of all the lamp radiations, you can find out the MESCP, that is mean spherical candle power. Okay, so by using this technique, you can find out the what is that? So mean spherical, and by plotting the different polar curves in a horizontal plane and a vertical plane, you can you can find out the mean spherical candle power as well as mean horizontal hemispherical candle power using these vertical polar curves by the Russian's criterion. Okay, this is about the brief idea about the what exactly the polar curves is. Okay, so this is very important. So polar curves is, so what is polar curve? Polar curve is nothing but it's a graphically we are representing the intensity, luminous intensity of a source of a light in a uniform directions, so in a uniform plane. Okay, but because of unsymmetrical shapes of this various source of light, initially that is we have always assumed that the luminous intensity of a source of light is uniform in all the directions. But what happens because of the unsymmetrical shapes of this various source of light? Okay, the luminous intensity will not be same, it is a different in different directions. Okay, so in order to know the luminous intensity of a source of light in a different directions, these polar curves are drawn here. Why these polar curves are drawn? So we have assumed that luminous flux or luminous intensity is same in all the directions in all the plane, but it is not true because of unsymmetrical shapes of various source of lamp. It is not true. That is why the luminous intensity will be different in different direction. So in order to know the luminous intensity of the source of light, we are drawing the polar curves here. Okay, understood? What is the necessity of polar curve? You may get the questions like what is the significance of drawing the polar curves, and explain the horizontal and vertical polar curves using the Russian criterions. So in that case, you have to first tell the significance of polar curves. So significance is to measure the candle power in all the directions in a particular planes. Okay, so the polar curves are which will represent the luminous intensities of a source of light in all the directions in a particular plane. Okay, it will be indicating the luminous intensity, or it will represents the luminous intensity of a source of light in all the directions in a particular plane. So if the polar curve is indicating the luminous intensity of a source of a light in a horizontal plane, so that is called as a horizontal polar curve. So if the polar curve is indicating the luminous intensity of a light in a vertical plane, that is called as a vertical polar curve. Okay, so this is a representation of a horizontal polar curve, and this is a representation of a vertical polar curve here. Okay, so this is about the polar curves and its construction, how the construction is happens, it is explained. Okay, so based on this we are calculating the luminous intensity of a polar curves. Okay, so that's about the polar curves. So next is measurement of the what is that measurement of the mean spherical and mean hemispherical candle power by using the different techniques. Okay, that we will discuss in the next video. Okay, so till then, so this is a polar, this is about the polar curves. If you have any doubts in polar curves, you can contact me. Okay, thank you.